Begin part B of section 8.2 that we cut off that last time. I'd done so much talking, I thought I was going to start coughing. So in this part, let's review. In section 8.1, we learned about the multiplication rule, where we said if I had the cardinality of the first set times the cardinality of the second set, etc., till we got all the sets, we got how many? How many choices we could have. Then, in that same section, we learned about permutations. And this was arranging one set of elements in a specific order. And in this one, we introduced the factorial. And we used the calculator to construct NPR. Now remember, N is the cardinal number of the set. That means the whole count. And R is the size of grouping of elements to be placed in an order. All right. So on 8.2, we're talking about combinations. This is the big one and most used because it is groupings of elements. Order not important. And the size, again, we have the N, which is the total number of elements in the set, only one set. And R is the size of the grouping. Again, we use the NCR, N choose R. Okay, so in the N choose R, the book uses C parenthesis N R, same thing. But for calculator use, we construct the problem using NCR. So let's get started. Get you caught up on what we just did. All right. So we're still talking about cards. And we know that the cardinality of the cards is 52. And we know that the cardinality of each suit is 13. In other words, 13 spades, 13 clubs, 13 hearts, and 13 diamonds. All right. So we'll need that information for what we're starting with right now. This example is finding how many ways is it possible to choose 2 hearts, 2 diamonds, and spades. Now notice it's an and. So we're going to use the multiplication. We find the combinations. Possible. All right. So we've got that going. All right. So let's see. So we want 2 hearts and 2 diamonds and 1 spade for a 5-card hand. All right. So we're going to do, we have 13 hearts and we're choosing 2, and we have 13 diamonds and we're choosing 2, and we have 13 spades and we're choosing 1. Okay, so we're going to do the math on this guy. And I'm going to clear everything. So I'm going to do 13 math, arrow over to probability, choose number 3 and put 2. And I get, it looks like 78. Yes, it is. And this one's the same. And now we know that 13 choose 1. There's only 13 ways to choose one grouping of 1. And so we're going to multiply those. And we're going to get 79,092 ways to get 2 hearts, 2 diamonds, and 1 spade. All right. And whatever fashion there it's dealt. That's how we would do that. All right. Now we're getting into the analysis part of our lesson. In other words, we're not talking the theoretical part. We're talking about what we have as sets and the quantity of each of those individual groupings within the set. So let's see what we have. Decide whether it involves permutation, order important, groupings, which is combinations, ing, or neither. And then solve the problem. In a club with 10 juniors, 16 seniors, how many 7-member committees can be chosen that have? All right. So we're going to be talking combinations. We're saying RN for juniors, it's 10. RN for seniors is 16. For all is what we're asking for is going to be the sum of those two, but we have 2 distinct sets. All right, all juniors. Okay, so remember, there are, the R is 7, because that is how many they want, 7-member committee, and it is groupings. So all juniors, so that would be 10 choose 7. All right. $120. From 10 juniors. All right, so we got the first one, 120. Okay, now let's look at the next one. 4 juniors and 3 seniors. So we have 4 juniors from that set and 3 seniors. All right. So let's look at that condition, make a little bit more room. So we're going to have the 10 juniors choose 4 and the 16 seniors choose 3. Okay, because it's the juniors and the seniors. So we're going to do the math. Now remember, you can do it all in one. In other words, you don't have to do individually, but I'm doing it for instructional purpose so that we see the numbers and see how they work. So this one is 210 and the 16 math, P-R-O-B, 16 math, P-R-O-B and 3. And we're going to choose 3. And enter, 560. And now we're going to multiply them to see how many combinations we'd have of the 2 individual sets. And I get 117,600. And the ways to have 4 juniors and 3 seniors. Okay, so 117,600. Okay, so now they're asking us in how many ways can we get at least 6 seniors, at least. So we could have 6 seniors and 1 junior, or 7 seniors and 0 juniors. Okay, so those are the conditions we have. So let's see. Okay, so we're going to have seniors are the condition. That would be 16 choose 6, at least 6. And then we're going to have times, and then we're going to have 10 choose 1 junior. Or means to add. 7 choose, our number 16, right? 16 choose 7 times 10 choose 0, because we've got at least 6, or all of them, right? So now we're going to do the math. Oh, clear that. Sorry. I don't know what I hit. Sorry about that. Let me clear everything. So I'm going to do 16 and we're choosing 6. And I get 8,008. Now I'm doing, oh, sorry about that. I'm not done. That was just one of them. Got ahead of myself, didn't I? And we're going to multiply that by 10 times 1. That would be 10. Okay, so I got that one. Plus, okay, 16 math, P-R-O-B, choose 3, and we're choosing all 7 in the committee, and enter, and anything to the 0 is 1, right? So we're going to do that one to, again, show you that you don't have to trust me. You can do it yourself. All right. So now I have 8,080 plus 11,440. And I'm going to add those up. Oh, I forgot a 0, didn't I? Add 9,520. At least 6 seniors in the committee. Right. Now we have this one. Uh, and this was, of course, a combination. All right. Now we have our last problem. And I know you're excited. From a group of 8 newly hired office assistants. So my N is 8. That's my pool. 8 assistants. 3 are selected. Each of these 3 assistants will be assigned to a different manager. In how many ways can they be selected and assigned? All right. So let's see what we can do with that. So in this case, we have, oh, it's 9. I put an 8, I guess from the last problem. I'm sorry. So we're going to have a combination. It is 9, choose 3, and then we're going to multiply by 3 factorial for how many ways we can assign them to the 3 groupings of the 3 groupings of the managers. So here we go. 9 math, PROB, number 3, and we're going to choose 3. It looks like 84. And 3 factorial is 3 times 2 times 1 times 6. So we're going to take that 84 and multiply by 6. 504. All right. So there you have it. Okay. A company sells hamburgers as well as a regular and a larger. So we got 2 types. Either type can include cheese, relish, lettuce, tomato, mustard, or ketchup. So automatically we need to assess what we have. We have 2 types of hamburgers. regular, and large. We have 1, 2, 3, 4, 5, 6. 6 um, additions because they are cheese, relish, lettuce, tomato, mustard, or ketchup. Right. 1, 2, 3, 4, 5, 6. Good. I counted right. Now we're getting to work. How many different hamburgers can be ordered with exactly 5 extras? Okay. So we have 2 types of hamburgers. It's 2 factorial. We're going to put 2 times, and we have from this part here, we have 6 choose, and we want 5. All right, so let's do that. I think we read it out. It didn't say a specific hamburger. They said hamburgers. So let's see what we're going to do here. So we're going to put 6 math, PROB, number 3, and put 5. And there are 6. 12 ways to have either hamburger, oops, sorry, with 5 extras. Okay, that was not hard. So let's see what we got here. How many different regular, okay, so it's specific, so that's a 1, can be made to use any of the extras. So, all right, any of the extras. Well, that would be 1, the regular, times, and we would have 6, choose 1. Well, that would be 1 times the 6, 6 ways. Okay. And how many different regular hamburgers can be ordered with at least 4 extras? So we have regular hamburger with 4 or 5 or 6 extras. Okay, well, this is an or. So we're going to have addition. So it's 1 type of hamburger times, and then we have on the extras is 6 choose 4 plus 1 times 6 choose 5 plus 1 times 6 choose 6. All right. So we really don't worry about the 1 so much, but we want to make sure that we have all the conditions met. So let's do this math. So this one would be 15 and this is 6. Oh, it's an or. That's a plus. You didn't, yeah, I have plus. Except for here. Sorry. Got to be exact for you. And now I have 626, so that is 1. Okay, so that is 21, 22 ways. All right. Now, this is something I took from the book, and it separates visually what takes place. If repetition is allowed, it's multiplication, and it's more than one set. If it is repetition allows is no, then does order matter? If it's yes, it's a permutation. If it's no, order is not important, then it's a combination. So there you have it. You've learned all 3 different ways of counting. And this was without drawing a tree diagram. Very helpful, isn't it? If we drew a tree diagram for everything, we'd go a little bit crazy. Now you're ready to do the homework. Thank you for listening.